Hello, hello. Okay, it's it will work now. I really need to, I think get a new software. The streaming software is not really good. Okay, now, so considering that, then we have to basically go to the next one. Let's hope this is what we're looking at. A ball mass m travels vertically downwards, okay, and hits the at speed u, and hits the ground at, okay, sorry, it hits here with the speed u, and then rebounds up with the speed v, right? The collision takes change in time. What is the average resultant force? So if I take this as positive and this as negative, because they're in opposite directions, right? So change in momentum is gonna be mv minus mu, and then the force resultant is change in momentum upon time, so mv minus mu delta t. And now it says what is the average result force exerted on the ball during, so ball will exert a force down, so it means the ball will feel a force up, equal and opposite, right? So that means it should be upwards, and I made a mistake here, sorry, it has to be minus mu, so this would give me mv plus mu actually, so it has to be d then. Okay, now if you have any questions here, please do let me know. Now this question, I think I've seen this before as well, but the raindrop wala question, I think it's repeated somewhere. So it says k is a constant, g is acceleration due to gravity, and graph shows the variation terminal velocity of raindrop with mass m. Fine. So what you do then? So we have terminal velocity right here, we have mass m here. So first of all, we have to make sure v is the subject of the equation. So we're going to take kv square on the other side, so it will be mg minus f, and then v square will be equal to mg upon k minus f upon k. Now check this out, my friends. First of all, I would say that what is on the y-axis. So the y-axis things are v squared, so I'm going to compare this with y, equals to mx plus c. This thing that you see here is on the y-axis, I mean v is on the y-axis, not v square, but still, and m is on the x-axis, which means that the okay, so the gradient will be g upon k, and the y-intercept will be minus f upon k. Okay, so right, so this means that, interesting, which graph shows the variation of terminal velocity with increase in mass? But you don't, you can't, I'm not getting the any y-intercept that makes sense here. Okay, so well, let's try to do it another way. So let's say kv square equals to mg minus f, and then v square will be mg minus f. You take root on both sides, and then when you take the root, okay, this is mg upon k root, okay, so this will be v equals to root of mg minus f upon k. which basically means that this function is between, it is not y is equal to mx plus c, because that graph is not given, so we can only use y is equal to mx. And now y is on the x-axis, x is on m, so basically, and basically m is a root function, so root function graph is always this, I told you last time as well. Okay, so do remember that. Okay, pretty good then. Now this graph, right? Okay, that's fine. Now going to ball mass m moving at velocity v collides with stationary ball 2m. So there is ball m going with velocity v collides with 2m, which has a, okay, u1 is v, and this is like u2 is 0. They stick together, so if they stick together, m and 2m, so they would be moving at speed v. And what is the fraction of initial kinetic energy lost on the impact? Now first of all, we need to find what exactly is this v1, let's say v1. Okay, so I'll make a momentum equation, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. This is m times v, this is 0, this is m plus 2m because they stick together, and now we want to find v1 actually. So basically now this will be mv equals to 3mv1. So basically the new velocity will be v by 3. So we need to remember this now. So initially the kinetic energy was half m and v squared, so this is initial, and the final kinetic energy was half times 3m and v by 3 square. So this is going to be half times 3m v square by 9, so 3 1 3 3, so this is going to v square over 2 by 3, okay, 6. Okay, so this is the kinetic energy final. So what do they want? What is the fraction of initial kinetic energy lost? So we're going to do basically there's m as well, sorry, half m v square minus v square by 6 m. So we could do half minus 1 by 6, and this is mv square minus mv square. Okay, so let's try this. Half minus 1 by 6, so that's 1 by 3 then. 1 by 3 is the kinetic energy remaining actually. So how much is lost on impact? So that should be around 2 by 3 really.
So could you explain again?
Yes, I'll do that again. Okay, so wait. First I'll need to go back and explain this question, so then I'll explain that. Please wait a second. Okay, so what you do, Mohima, is that you see terminal velocity is on the y-axis, so we need to make sure that this equation that is given, we need to basically make it the subject. So if you take kv on the other side, it will be kv square equals to mg minus f, and then you can divide this whole thing with k, and then what you do, you take root. So when you take root, v will be the subjective equation, and now it will be mg minus f over k. Now you see that in this particular equation, the relationship between v is basically of under root m, and you just need to remember there are three types of graphs. One graph is when v is directly proportional to m, it would be a straight line. The other relationship is that if v is proportional to something m square, so it will be like this. And if something is proportional to under root, then it is like this. So that's why we chose B. Alright, I hope you guys understand. Now, going to question number 10 again. So what I did was, there was mass m that was moving with speed v, and then mass 2m which had 0. This is u1, this is u2, this is 0. Afterwards they stick together. Okay, now this is m and this is 2m, and that's they would go at v1. We don't know this, right? So we need to find this v1 in order to find what is the kinetic energy loss. Do you understand? Ahmed?
Yes.
So what you do is that you first find the velocity. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this is going to be m times v. This is going to be 0 because it's stationary. This will be, the masses have they stick together, so it means you have to add them. So m plus 2m and v1. So this will be mv, and this will be 3m v1. So m and m cancel, which means v1 is basically this much. Is it clear?
Yes.
What they're really asking in this question is that which fraction of initial kinetic energy is lost on impact. So if I find the initial kinetic energy of both of them, so it is going to be half, because the kinetic energy of this guy is 0, right? So half m times v squared, right? So this will be half mv squared. So this is our first equation. So this is initial one, right? Now we can find the final kinetic energy of both. How do we do this? Half times the total mass was 3m, and the speed that they were actually going was v by 3 square, right?
Yes.
Now, so this will be half times 3m, and this is going to be v squared by 9, right? So 3 1 and 3 3. So basically what you get is, you get basically can I write this equation as 1 by 3 times half mv squared? Can I do that? You wouldn't mind, right?
Yes.
Okay, fine. So what is the change in kinetic energy really? So you do initial, because it's losing, minus final. So initial was half mv squared, and the final was minus 1 by 3 times half mv squared. So when you take the change, this is going to be 2 by 3, and that's the answer. Do you get it?
Yes.
So whenever such question comes, right, you should always remember that do it step by step. They will take some time, right? Now you see, the thing is that these type of questions that we did, this type of question, maybe this type of question, they just take like 10 seconds of your time, right? But these questions would actually use up like 2 to 3 minutes, which means that some question needs to be addressed with more patience, and the other ones rather quickly, because they're just definitions. Now
There, over here, the last step, the answer is 1 over 3, not 2 over 3.
How?
This half mv squared minus 1 over 3 times half
mv squared is the common thing, right? So if I take common, this will be 1 minus 1 by 3, and I can take half mv squared as common. So this will be 2 by 3, right?
Oh yeah, okay, got it.
Do you understand now? Okay.
Yeah.
Okay, now then what you do is that you say, what causes the upthrust on a submarine? So basically this is asking the definition of submarine, and that has to be, there is a difference in water pressure acting on top and on the bottom. This is the principle behind upthrust, so it just takes you like 2 seconds. Okay, so make sure that you look at that. And then two forces, each of magnitude F along. So this is a couple, I can see that. So what is the torque? So last time I told you torque is basically force times the distance. This is the distance between two forces, right? So the distance that is perpendicular between two forces is B. So that would be F times B then. Okay. Now, so pretty easy. Now let's go this. So this is non-uniform rod, has a mass 100 grams and the length of 50. Fine. Supported by chain at midpoint. The rod is held in equilibrium by having a mass of 60 grams here. Okay. Okay. All right. The center of gravity rod is distance d from its left hand end. So this is the center of gravity. Okay. What is the value of d? Okay, so first of all, the thing is that this chain would actually be, it is supporting, which means there has to be some force on top of it, right? So what we can do is we can take it as a pivot. If we take it as a pivot, then actually about this pivot, this will try to rotate it clockwise and this will try to rotate it anti-clockwise. Now what you do, then you just use clockwise equals to anti-clockwise, and then clockwise would be basically 60. You don't need to find the weight because they have the same unit, so they will cancel out each other. It doesn't really matter. Now the distance, it is supported chain at midpoint, which means this distance has to be 25. So I'm going to multiply 25 here, and then this is 100 grams, and this distance, basically this distance is what we need. This distance is going to be, basically the whole distance is 25, right? So this distance will be 25 minus d. So we can just write 25 minus d like that. Okay, so 60 times 25 is going to be 1500. 100 times 25 is going to be 2500 minus 100d. So let's try to solve this. So 2500 minus 1500 divided by 100. Okay, wait, that would be wrong. Divided by 100 would give me 10 centimeters actually. So which means A is the correct answer. All right, if you have any questions, please let me know. Pretty good. Now then comes this one. It says a rigid rod xy, okay, has an object of weight W fixed at one end. The rod is in equilibrium resting on support Z. Where is the support Z? Okay, fine. And then vertical wall X. The support exerts R on the rod. The diagram shows directions but not magnitudes of R and W. What is the direction of force at X? Now the thing is, we should basically what you guys need to understand is that in an equilibrium, when you complete the shape, it should move in one go. So if W is like this, right, and I can connect R like this, right? So W is this, R is this. So it means the force that we're looking for should be like this. So that's XY, because then it completes the whole, loop. So that means 14. But that means 14 can either be A, or it says it could be either A, B, or D. But because they say the directions are not shown, the magnitudes are not shown. So we have to somehow think about it. Why what can we do about it? Because this could also be like this, right? If W was like this and R was much bigger than W, then this would go like this. So we have to think what way it is going to be, right? It is going to be like this or that. This is what I need to think. So one thing that I should understand in this is that this is absolutely wrong and this is absolutely wrong. Why this is wrong? Because this is not giving me the right direction. So it could be either this or it could be either this, but by both of the diagrams that I made. The thing is that not only this Z is supporting a W, it is also supporting the weight of rod, right? Which means the reaction has to be much greater than W itself. Otherwise, it can't support it, right? So this means that R must be bigger in size than W. So this is a clever question. So if W is like this and R is much bigger than this, then the X should be somewhere here, which is D actually. Now, somebody basically asking me how do I know 100 grams, which is this, is rotating it? It's rotating it anti-clockwise, not clockwise actually. Oh yeah, okay. So how do you know 100 gram makes it rotate? I know this because if I take this as my pivot, right? So forget about everything, just focus here. You see that if you push down from here, the rod will rotate like this, which means that this will cause a turning of anti-clockwise, only this force. That's how I know, just by visualizing that how would rod rotate if all forces were removed, only this was there. I hope I've answered your question. Okay, so for vectors, I will try to upload a small say a file. You can actually practice them. It will really help your understanding. It has a lot of MCQ questions in it. I will try to upload it today. Alright, so liquid Q has twice the density of R, and at X the pressure is 4 kPa. Which depth Q the pressure is 7 kPa? Okay. So the density of Q is twice the density of R. Fine. At depth X, the liquid R, so there is depth X. Liquid R has a pressure of, so for R the pressure is 4 kilopascals. At which depth Q is the pressure, at which depth Q is the pressure due to liquid is 7 kPa. Pressure is rho GH, right? Now in this one, for liquid R, pressured R, rho is just yeah. What can we do about it? Yeah, we can just write R, rho R, G and X. So that's our first equation. For Q, it is going to be 2 rho R times G, and at which depth, and we need to find this depth here. Okay, so this pressure was 7 kPa, 2 rho R times G times X2, and this pressure is 4 kPa, and this is rho R times G times X. Now what you're going to do is think here I can take X2 as my, if I divide X2 on the other side, so it is going to be kPa over X2 and divide by 2 as well. So I will get rho RG, and on this side I will get 4 kPa divided by X equals to rho R and G. So these two factors are basically same, so you can actually put them together. Okay, so when you put them together, it will be 7 kPa over 2x2 equals to 4 kPa over X. So this now we just need to find x2. So 7 times x over 2 times 4. What you do then? This paper is like very long. It's not very hard, but it's long. Wait, let me see. 7 divided by 2 divided by 4. So that's 7 upon 8. And that would be this answer easily. Okay. Let me know if you have a question. I want to explain. If you need me to explain it again. Okay. Now going to this question, it says trolley starts from X and eventually rolls down to Y and then comes to rest. So here it has speed 0 and here it has speed 0. Fine. So which row is possible summary? So when it is moving here, so definitely gravitational potential energy will go into kinetic energy. But nowhere in the question it says that this track is frictionless. So it means there is friction, and which means some of the energy will also be lost to heat. Okay. So from X to Y it will be like this, and from Y to X it will be kinetic energy will go into gravitational potentially again, and it will cause it to lose heat as well. I mean gain heat as well. So which would be correct? Heat. Okay, that would be right. Now the cylinder is heated, causing the air inside to expand at constant pressure. The moment I hear this, right, I should remember that probably this is a work done question, and work done is pressure times change in volume, because this formula is only for constant pressure. So you should remember that. Now, so it says what is the area of cross section? Okay, I think we can do this. So first of all, work done is pressure times change in volume can be written as area times change in height, right? So work done is 11,000. Pressure is 2.2 times 10 raised to 5. We want to find this area, and the change in height is this much, 0.50. Okay, let's try to do it. 11,000 divided by 2.2 divided by 10 raised to power 5. So we got this, and then divided by 0.50. So this is like 0.1, right? Is there an answer like this? Yeah, 1 into 10 raised to minus 1 meter squared. So it has to be D then. Fine. Okay, then talking about the next question really. So going to this one. The point X at a height of 4 above point Y. The speed of ball at point X is 2.5. The friction forces are negligible. What is the speed of ball at point Y? Okay, so first of all, I should understand that gravitational potential energy will go into kinetic energy. We don't have the mass of the ball, right? So it doesn't really matter, because mgh will go into half mv square, so we can put it equal. M and m will cancel out. This will be 9.81, this will be 0.40, this will be half times v squared. So what you do then? 2 times 9.81 times 0.40, and then you got to take root, because we need to find v. So v will be 2.8 meters per second, right? And also its initial velocity was 2.52. Okay, so 2.8, but the thing is that it's talking about the speed. Yeah, it's talking about
there was some kinetic energy at X as well.
There has to be there is something different about this, है ना?
Yeah.
2.8 plus 2.5 doesn't really give me any answer really. So it has initial speed like this, and the height is this. So because of this height, it should basically gain kinetic energy. Let me check if I've not made any mistakes here. 2 into 9.8 times 0.40. Doesn't seem like I've made a mistake here. But why would it give me this? Interesting. What is the speed? There is no frictional forces here. It should gain speed here. It should be added with this for sure. But why? Why would you not give me this? Okay, wait a second. This actually means, let me think about it this way. If the speed is rising like this, right? So it was at 2.5 and this is now at like 2.5 plus 2.8 plus 2.5 is 5.3. So now it should be at 5.3. So we just need to find what is the speed at that point. The speed would not be like this. So let me say 5.3 tha na? 5.3. Sorry, 5.3 plus 2.5 divided by 2 gives me 3.9. That should be actually this answer. I'll tell you why I selected this. Let me tell you. This is a very good question actually. So the thing is that it's talking about you just can't, add them together directly. The reason is that as the speed is increasing, it already has a speed like this, right? So basically what happens is that there is an increase in kinetic energy. So it had some kinetic energy before, so let's say u square, and then now it has kinetic energy v square, right? So we have to find the total kinetic energy and then we can only find the actual speed. That's the thing here. Okay, now what you do, so what I've done is I've thought about it like this, that basically if 2.5 was the speed initially, it has gone up to 5.3 because the new is this. So what I did was I added them together and then I took basically what would be the average of it. There is another method, I think it might work. Let me try that. Let's assume that mass is 1 kg. Okay, just to make things simpler. Which means that the kinetic energy initially was half times 1 times 2.5 whole square. Okay, so let's try to find this. 0.5 times 2.5 whole square. Oh no, 5 whole square. So this gives me about 3.125 joules, and kinetic energy after was basically equal to mgh, right? mgh. So that would be one mass 9.81 and the height was 0.40. So let's try this. 9.81 times 0.40, so that's 3.924 joules. Okay, then the total kinetic energy now that it should have is 3.125 plus 3.924, 7.049 joules. Okay, now so I can use it to put half times 1 mass times v square. So just to check whether my analogy in the previous question is, the previous method is correct. And this is 2, and then we take the under root, so it gives me exactly the reading 3.8 meters per second. So that's the answer. So basically Yeah. So basically what I did was I thought it this way. Kinetic energy always changes like this. It never goes like um, this, right? So, or this. So basically what I thought was that if it had 2.5 and according to this equation I got 2.8. So I thought if this was 2.5 here, then 2.8, the gain in velocity would be 2.5 plus this would be 5 point basically 3, and then I had to take basically 5.3 plus 2.5 divided by 2. That also gave me like 3.9, was close, but this should be the actual method that we should be using. Okay, if you have any questions, please let me know. Now, this is a very interesting question, very nice. Now, at which rate is its kinetic energy increasing? So first of all, I'd see that this whole thing and this whole thing is balanced, so it means the force, resultant force, is to be 500 kilonewtons minus 200 kilonewtons. That basically gives me 300 kilonewtons, right? So it says at which rate the kinetic energy is increasing, right? So power is what we need to find. 300 times 10 raised to power 3 and velocity is 40. So let's 300 times 10 raised to power 3 times 40. So that would be 12 and C. Okay, so this is pretty easy. And now let's go to the next question. So the diagram shows a simplified model of a building 4 identical floors. The spacing of the bottom floor from the ground is twice the spacing of the floors, twice between the floors. Between each floor, equal number of vertical steel supporting rods. What is this question? Oh my god! What is this question? The spacing of bottom floor from the ground is twice of the spacing between the floors. So it means if this was 2x, it means this was x, this was x, this was x. Okay. Between each floor are equal number of vertical steel supporting rods. Okay. Rods of negligible mass compared to the floor. The rods of different diameters, so the stress in each rod is the same. Okay. So what is the ratio of diameter of bottom rods and the diameter of top rods? But the thing is, there are 4 identical heavy floors, so it means this will be mass m, 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 right? So stress is force over area. Let me think about it. And area would be actually pi by 4 d square, right? So then what you do on this rod, these rods, actually there are 2 rods, there are multiple rods or 2 rods, equal number of vertical steel supporting rods, doesn't really matter. So on this rod you have basically the force that is acting is 4 mg. So the force here will be 4 mg because it's supporting this and everything else, right? So the stress on bottom would be equal to 4 mg, and let's call this d bottom square. Okay. Interesting.
But sir, isn't this parallel arrangement? So wouldn't each rod get 2 mg?
Well, they have shown it, but they say there are multiple. They are the equal number of vertical steel rods. So how do we know how many rods are there? We don't know, right?
Yeah.
This is interesting. Okay. And on the top, it says top rods. On the top, this will be like 3 mg, this will be 2 mg, this will be just mg. And then it's like, what is this really? Okay, let me work it out. Diameter 4 mg, and on the diameter of top rods, each rod should be going through this. Okay, there has to be some logic that must be there actually. So never mind, let's try to make d squared be the subject of the equation. That would be 4 mg over pi by 4 stress, right? Okay, now so this means the bottom rod will have 4 mg over pi by 4 the stress. Fine. Okay, and now the diameter of the top, so the top stress would be actually then this would actually mean that there are 4 W's really. So there is 4 here, and then there is 4 rods on top. It's very strange. Lifting that and 4.
No, sir, because they have the same stress, you just equate them to each other.
Stress would be same. Yeah, I'm trying to figure that out. Actually, I'm trying to figure that out. So then they're like here same stress means that it should show me like at B there are 4 different stresses, and each one is projecting like 4 mg over pi by 4, and then dt, okay, square. Okay, dt would be then 4 times 4 mg over, I'll explain it. I'm trying to figure this out, and then this is the stress. The stress would be the same because it's causing it from the top. Fine. So what you do then, this is under root. Now bottom over top, that's what we're going to do. So it means that this is bottom over top, right? Interesting. This is bottom and this is top. Okay, now I get it. Sorry, let me do it now. Now I understand this easily. It will be done. Okay, so let's say that the weight is equal to mg. So 4 times 4 would be 4 mg, because that's here 4 mg, right? Now stress is equal to 4 mg over just because this is a function of d square, so we'll keep d square right here. And then what you do then, the stress, this will be at bottom, and then at top it will be mg over d square. Okay, now let's this is bottom, this is top, let's take it there. D bottom will be equal to 4 mg over stress, and d top is going to be actually mg over stress. Okay, and now they say take the d bottom over d top. Okay, so if I do that, then this will be equal to 4 mg over stress divided by mg over stress. Okay, so mg and mg cancel out. So now we got basically 4:1, and then when you take the root, it will be 2. So that means this answer has to be 2. Wow. Yeah, yeah, that's correct. That's correct. That's correct. But that is the answer. Do you guys understand this? If you have any questions now, please let me know. Interesting. Wow, this question is so good. I should include it in notes. All right, now going to the next one. The Achilles tendon is a rabbit-legged stretched when the rabbit jumps. What is the strain energy in the tendon when the tension is 400? This, so 400 means that you have to go here. This I think is 37, and this I think is 35. So the original length was like 35, so the extension will be 37 minus 35, 2 millimeter, which can be written as 2 times 10 raised to minus 3 meter. Now what you do, F equals to F into X into half equals to energy, so half times 400 times 2 into 10 raised to minus 3. So this will be 0.5 times 400 times 2 times 10 raised to power minus 3. This is 0.4 joules. Okay, so let's see, 0.4 joules. Fine. So what you get is A. All right, now let's move to the next question. Now the amplitude wave has intensity I. After passing a certain medium, the new intensity is I by 4. What is the intensity? So I gave you this formula, I1 over I2 equals to A1 square over A2 square. So now you can easily do this. Intensity I and then I by 4, and this is equal to what is the new amplitude? If the amplitude was A square, what is A2 square? So I and I will cancel out, 4 will go on top. So A2 square will be A square by 4. You take the root. So the new amplitude will be A by 2. A by 2, 22. Right, so this is just a simple ratio that you got to use. Now, wave travels here. What is the frequency of the wave? So you have time. This is from here till here, you see this is 1.5 wave, which means 1.5 time period is equal to 0.2 seconds. So the time period will be 0.2 times divided by 1.5. So 0.2 divided by 1.5 is basically 0.1333, and then frequency will be 1 divided by answer, so 7.5 hertz. That's T. Okay. Now the frequency is this, and stationary wave is produced. Nodes are shown. The speed of wave is this. What is the value of this? First of all, we'll find this, the lambda. V is 336. This is 1200, and we got to find the lambda. So 336 divided by 1200 would give me 0.28 meters. Now if you check this out, this is a node, this is a node, node and node. So this is half lambda, this is half lambda, this is half lambda. So you got 1.5 lambda equals to 0.28. So no, sorry, 1.5 lambda is x. Sorry, so x will be 1.5 times 0.28. So 1.5 times 0.28 is 0.42. 0.42 meter is actually 42 centimeters. B. Yeah, that's correct. Now going to the next one. The stationary source S emits a sound wave of frequency F. The source now moves away from the source. Okay. Which statement is correct? So basically, the observer and the source is moving away from the observer. Okay. Moves emits frequency F. So if it's moving away, so it means that the frequency of source S and observed frequency are now both higher. That's wrong. It's moving away, so it would be lower. The frequency of source S and observed frequency are now both. This doesn't change. It's not lower. That's wrong. Basically, this is wrong. And this section, this section is right. The frequency of source is now lower than F. That's wrong. Source frequency doesn't change. The observed frequency is lower than F. That's correct. Now, the table lists possible wavelengths of different electromagnetic waves, which is correct. Okay, so the first one is infrared, and that's correct. Infrared is in this range, right? Because, yeah, yes, infrared should be in this range because infrared comes after red, and red is basically 700 nanometer. So basically 7 into 10 is to minus 7, right? So it should be lower than that, higher than that actually. So that's correct. Radio wave, this is too short. Ultraviolet this is too long. This is too short. X-ray is not this. This is light. That's why A is correct. You should remember this, by the way, now. Okay, a vertical tube is partially filled with water. A sound wave moves down a tube and reflected surface of water. The frequency of sound waves gradually increased from 0 until a much louder sound is heard. So first of all, an antinode is formed here, a node is formed here. So this is one end open and one closed. So the formula for this is that frequency is V times N over 4L, where N in this is 1, 3, 5, 7, all odd numbers. Now it says water is then removed from the tube until a second loud sound is heard. Which diagram shows the new pattern of stationary wave that is formed? First of all, a node will be formed here. So these are absolutely wrong. And then which means that here a node cannot form here, so that's wrong. So C is the correct answer because it has one antinode here, one antinode here. So this is the first loud sound would be heard here, and then the second loud sound should be heard here. Very good, actually, everybody. Okay, now which diagram shows the waves after they pass through the gap? What is this? That's wrong. That's wrong. This now this could be correct and this could be correct. Now how do you choose which one is what? So first of all, you see that this wavelength and this gap is almost the same size, which means that it would give you a circular pattern. If this pattern would have occurred if this gap size was larger, so then it would occur. So that's why it is A. Alright, now next, the double slit experiment is now set up using green light and pattern interference fringes are formed on the screen. Which single change will increase the separation of this? Okay, so AX equals to lambda D. We want to find the separation, so let's put it here. Okay, now then which single change will increase the separation of fringes? If you increase the width of the slit, what is the width? This. If you increase this, the separation should decrease, so this is not the answer. Move the screen nearer. If you reduce this distance, X decreases. That is not the answer. Use the slit that are further apart. If you increase, again, further apart means that you're increasing the separation. This would decrease this. This is wrong. Use red light. So if you increase the wavelength, you get x would increase, so that has to be t. All right. Now, going to this one, diffraction grating. The plane of diffraction grating is right angles to incident. A student looks at the grating from position near the grating. What could student see? Okay, so the student, a central point source with series of point sources images on either side. What is this? Series of point sources images on either side. Series, okay. Then a central vertical line with series of spectra. That's wrong. That's wrong. That's not true. This is basically a question about white light. What happens is, in white light, in the center, there is no color. In here, you see violet, and then you see red, and then you see violet, and then even larger, like this. Yeah, and it increases. So, series of vertical lines. You just don't see series of vertical lines. So it means that here there will be no light, and then there will be light, and then there will be light. No light, light, and light. Yeah, this makes sense. A single point source, that is not correct. With refraction is going to happen. Central point source, you can't see the center thing because light doesn't disperse from the center, so this is also wrong. So it means a series of fine vertical lines would be the correct answer when you look at it from the front, right? So it would give you an image like that. Makes sense to me more. Then you go to the next one. This is not required. This is not required, although this was very easy. So unit of electric charge is the coulomb. What is meant by 1 coulomb? So this is a definition question. Charge passing a point in 1 second when current produces 1 joules of work. How could current produce 1 joules of work? That's wrong. The charge passing a point 1 second when current producing 1 watt of power. What? The charge passing a point 1 second with this current of 1 ampere. That is the definition. Resistance. What are they even talking about? Okay, so now this one. The wire P has a diameter D, wire Q has a diameter 2D. What is the ratio of average speed? So what we need to do is, the formula is, I equals to NAVE. So I'm going to write I, NAVE, and then I'm going to write P, and then I'm going to write Q. Because area is there and there is diameter, so I'm going to add diameter in the, let me write it separately. I, N, A, V, E, and D. Okay, P and Q. Now, current is same for both because it is series, right? N is same wire, so N is same. Area we'll talk about. Drift speed P, drift speed Q, E is the same thing. Now D, so the diameter P is D, diameter of Q is 2D. So it means area is a function of D square, which means this will be A and this will be 4 times A, because when you square 2, it will be 4, right? Now we get everything right. So for P, I'm going to write I equals to NA VP E, and for Q, I'm going to write I equals to N times 4A VQ times E. And now what you're going to do, we have to take the ratio of drift speeds. Okay, so what you do then, VP will be equal to I over N AE divided by VQ, which is I over N times 4AE. So I and I will cancel out, N and N will cancel out, A and A will cancel out, E and E. 4 is double dividing, so it will multiply on top. So VP over VQ will be equal to 4. That's how you do this. All right, if you have any questions. Now, if you feel this is difficult for you, so you can always write like, I over NaE divided by I over N times 4Ae. Then what you do? You can take Vp over Vq as I over NaE multiply by, you can take the reciprocal, 4Ae over I, and then it's easier to cancel. So then it will be 4. So it's up to you. Now let's move to the next one. A power supply of electromotive force EMF is negligible internal resistance, whatever. What is the value V? Interesting, very nice. Okay, so first of all, I would like to find the voltage here. Okay, so V is equal to IR. 3 times 4 is 12 volts. 12 volts on this side, which means 12 volts on this side. So here the current will be V is equal to IR, 12 current and 2. So the current will be 6 amperes. So here there is 6 amperes. Now the current 3 ampere and 6 ampere, it means the total current here will be 3 plus 6, which is 9 ampere. Now the voltage on this one will be V is equal to IR. So 9 amperes times 3 is going to be 18 volts. Nee, what? 9 into 3 is not 18. 9 into 3 is 27 volts. So what you get total will be 27 volts plus 12 volts, because this section and this whole section is in parallel. So 27 plus 12 is 39. Has to be C. Okay, pretty good. Now there is one more method to this. I would like to discuss it. If you like it, you can also do this. Okay, let's try to do that. So first of all, let's take this section separately, right? When you want to find the voltage here, this will be V is equal to, then if the internal energy if the internal resistance is not negligible, it will be here. So you have to then also find the voltage for this one using the same current that we found. I don't know, it was 27 ampere or whatever, 9, I don't know what that was, 9 ampere, sorry. So you have to use that to find this and then add all of them together. Anyway, so then we use I and R, so you get 3 into 4, that is 12 volts. Now take this section separately, mark it 1, this section separately, mark it 2. Now what you do, you want to find the voltage in this, right? So you can use potential divider here. The total resistance here in the first one will be actually 1 upon 4 plus 1 upon 2, that will be 0.75, 1 divided by answer. So this is basically 4 by 3. So the total resistance is 4 by 3, and now you can use the potential divider. So we want to find V2. This will be, you take 3 on top, then you take 3 plus 4 by 3 and then multiply. Oh, we don't have that, unfortunately. We can't use this. We can't. No, we can. Okay, so we know we can use it like this. Sorry, we can use this V1. So instead of V1, if you use V1, right? Wait a second. So V1 equals to R. This is the potential divider formula, and we want to find this V. Okay, so this will be 12. This is 4 by 3 divided by 4 by 3 plus 3 times V. So this is a shorter method. If you like, you can actually use this 4 by 3 divided by 4 by 3. Okay, I got to use basically 4 by 3 and plus 3, otherwise it would give me the BOD mass error. Okay, this and then 12 divided by answer. So that would give me 39 as well. So this is a shorter method. If you like, you can use that. Otherwise, you can use the previous one. That's fine. Okay, if there was another resistance, like, you know, a resistance here, small resistance, then basically the total would be, let's call the total resistance R1 is this. This is, let's call this R2. Let's call this R, and the current was like 9 volts. Let's suppose 9 ampere. Let's suppose. So then you would use the voltage total would be I times R1 plus I times R2 plus I times R. So you have to add the voltage here as well. I think I answered your question. Okay, then the wire of heating element has a resistance R. The wire breaks and replaced by a different wire. Data for original wire, data for that. What is the resistance of the replacement wire? So let's add resistance in the table as well. So this original wire had R, and now we want to find R2. So we also need to add area. So area, if this is diameter D, we write A, and this will be 4A. Now R equals to rho L upon A, so that's the first wire. Okay, that's right. And for the second wire, it will be R2 equals to 2 rho times length over 4A. Okay, now what you do? You want to find R2, right? You can divide them. R over R2 will be equal to rho L upon A divided by 2 rho L over 4A, and then you do R over R by 2 equals rho L upon A multiply by 4A over 2 rho L. So A cancels, L cancels, rho cancels. So this is going to be 4 by 2 is 2. So R over R2 is equal to 2. So R2 will be R by 2. So that answer has to be B then. Okay, if you have any questions, please let me know. Now, the next thing. A fixed resistor and variable resistors are connected in series with a cell that has an internal resistance shown. Okay. And the graph shows a variation of quantity X with the resistance R of the variable resistor from increased from 0 to maximum value. What could X represent? What is this actually? I don't even know this. But let's make a let's say the current was I, okay? So, and this is the EMF. Okay, so EMF will be equal to I times, let's call this R1. I times R1 plus I times R2 plus I times R. Now, if I see this graph, there is a y-intercept. Okay. Y-intercept. Okay. And this is just R. So I want x-axis to be this. I want that unknown quantity to be this. Fine. Okay. So E minus IR equals to IR1. What is this fixed resistor? I don't know why they've given this even. Okay, let's not think about it. So, balki, this whole thing is the terminal potential. Okay, and the terminal potential is equal to IR plus IR1. This is the voltage here, which is here. Okay, so now I can compare this equals to Y is equal to mx plus c. Here it is interesting. It's not mx plus c, but there is intercept. So this shows me an intercept. This is the x-axis, and this shows me the potential, terminal potential. So this has to be terminal potential because this is a y-intercept. And let's see, the current in the circuit, nope. The electromotive source, nope. The potential difference across the internal resistance, nope. That's right here. And terminal potential difference, that's correct. Okay, no. All right, now let's go to the next one. If you have any questions here, please let me know how I did this. Okay, now which range of potential difference can be obtained between X and Y? So we have 4, we have fixed resistor, and we have a variable or potentiometer. Okay. So let's try finding what is the total potential here, right? So if this was connected, like, let's suppose if this was connected here, Y was here, so this would give me the total potentials. How do I do this? 3 over 3 plus 1 times the total EMF will give me V. So 3 over 4 times 4, this gives me 3 volts. So the maximum value that we can achieve here is 4 volts, and the minimum value would be, if Y was connected here, it would be 0. So the range of this question would be, oh sorry, I got 3 volts, not 4 volts, 3 volts, sorry. So 0 to 3, let's be this answer. Okay. Now, the radiation from a radioactive source has a range of few millimeters in air and can be deflected by electric field. What type of radiation is emitted? Alpha radiation is few millimeters, beta is few centimeters. Which equation describes beta plus decay? Okay, so in beta plus decay, you should always remember that a down quark, no, not a down quark, wait a second, a neutron would actually, a proton would change into a neutron and give you a beta positive, and then it should give you electron neutrino, right? So let's see if it works. Yeah, it does work. Okay, fine. So proton is up, up, down. This is up, down, down, and this is beta positive, and this is this. Okay. So do we see anything interesting here? Up, up, down, 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 and this one. Okay. One thing I just want to remind you: with beta negative, anti-electron is released, and with beta positive, normal neutrino is released. Okay. Okay, then that's pretty much it then. So this was pretty good. So let me see what was the grade boundary here, because I feel this paper is tough. This paper is tough. Let's see if we have grade boundaries for this. 2020. Oh, May June did not have it, sorry. But this paper was excellent. Excellent paper. Very good. So if you have any questions, please let me know now. Anything you want to discuss again? All right. So I guess I'm gonna see you people in the next. Oh, by the way, we need to discuss what time should I take the next class. So basically, I will be leaving to airport at 2 p.m. Pakistan time, right? So can we do class at, say, 10 a.m. Pakistan time? Can we do that? Only tomorrow.
Yes, sir, that time is fine.
10 a.m. So class tomorrow at 10 a.m. PK time. And what you're going to do is, we haven't done October, November, right? So October, November 9702, 2020, paper 11. That's what we're going to do. All right then. See you people. Bye. Have a nice day or night, whatever it is. All right. Bye. Allah Hafiz.